All right, let's look at knowledge check 6.3.1. And in this one, we want to use the Ames training data, and we want to fit a multiple linear regression model where sale price is a function of the ground living area and garage cars. Let's go ahead and do this. So let's just go ahead and call this LM-M2. And what I'm going to do is first create my linear regression object, and then I want to fit a model that is sale price is a function of GR live area plus garage cars. And the data we want to use is the Ames train. All right, so we've done that. Now let's go ahead and let's take a look at our model results. Tidy LM-M2. Whoops. And we see now we have our coefficient estimates for both our ground living area and garage cars. In this case, we can see both of the p-values for these estimates are quite small, pretty much 0. So that means that both of these coefficient estimates are statistically significant, or we can have pretty strong confidence that they are different than 0. All right, so how do we interpret our coefficients? Well, we see that ground living area is 78. That's our coefficient for that predictor. And garage cars is 42,643. So what does this mean? Well, what we can say is all things being equal, if we simply change the square footage of a home, we can expect to see for every 1 square foot increase in the living space, we can expect to see about a $78 increase in the predicted sale price. Okay. Now, what you heard me say at the beginning is all things similar or all things consistent. Basically meaning if we hold all other information constant, when we increase this predictive variable, we see this type of an impact to the sale price. So that means if you have a house, 2 homes, they both have 2-car garage, but one has 1 square footage more than the other one, we would see the predicted sale price be $78 more. Okay. Now, if we look at the garage cars, now what this says is all things being equal or all things being constant, for every additional car that a garage can hold, so as you go from a 1-car to a 2-car to a 3-car, for each additional car that a garage can hold, we tend to see about a $42,643 increase in the sale price. All right. So next was let's compute and interpret the generalization RMSE for this model. Okay, so let's go ahead, and what we can do is take our model object and we can predict on the Ames test. So recall we want the generalization RMSE, so we want to use the test data. And then we can go ahead and bind this with our Ames test data. And then we can go ahead and compute the RMSE, where the truth equals sale price and estimate equals dot bread. And now we see that our RMSE is 49,162. All right, so how does this model compare to the model based on the ground living area? Well, recall that the model just on the ground living area was about 55,000 was the RMSE. So we have actually been able to reduce the average prediction error by about $5,000 to $6,000 by adding garage cars as a predictive variable. So we can say now with these 2 predictive variables, we can say that on average, we can expect our model to be off by about $49,000 between the model's prediction and the actual sale price of a home.